Okay, this last tutorial is going to be very fast. That's basically, you've set up your map in GIS. You have some layers that you've downloaded. Let's say the hydrography layer, the city parks layer, airport, stadium, universities. And you want to take these and you want to bring it into Rhino or AutoCAD or whatever, because you want to start modeling stuff in 3D. So what you do is, you pick the layers that you want, and more importantly, you pick the extent that you want. So let's say, you want, let's do a small area. Let's do like the downtown area like this. Like this. And so this is the area that you want to export to CAD and get some CAD layers for. So what you do is you go to your geoprocessing tools here, and then there's a tool called Export to CAD. So just search for that. And it's the first one that shows up, Export to CAD. So click on that, and it's pretty straightforward. Basically, input features, you just put all the layers that you want to export. So you can either select from this drop-down menu here, or what I like to do is just drag it in like so, just so that it's just a bit more of a intuitive way to put your layers in. So let's just do a few of these layers. City parks, hydrography.
What would have been the alternative to doing that? Typing it?
Clicking this drop-down menu here and just selecting it. So once you have the layers that you want to export together as one thing, in output type, it already like it defaults to DWG, whatever. That's all you need to do. All these other versions, it's DWG. I never changed it. This is it. Output file. So you want to save this in a location you can access. So I'm going to save it on my desktop here. We'll call this one Montgomery AL. And so that's the file format that we're going to choose. I'm not going to hit run yet. There's a few other steps we need to do first. So you go to the Environments tab, and then Output Coordinate System. You want to set this to be your current map. This is really important. A lot of people forget to do this because doing this ensures that the units of your CAD file are actually in the correct units. Sometimes if you don't do this step, your units might be completely different from what you want. Correct. Yes, because remember the very first step we did at the very beginning of this is that we set the coordinate system to be the Alabama East feet. So because I knew that from the very beginning, I just need to set current map, and that it inherits that. The second thing you do is in the extent here, you set that to be current display extent. Again, this is the same thing where like if we don't choose that, it exports everything. And sometimes that just creates a really big file or a really unmanageable file. So current display extent only exports what you see here. Now you're ready to go. Now you hit run. So hit run. So it's going to export the CAD. As it exports, I'm going to open up Rhino just so that I have that opening as this thing exports. And you'll see the result is pretty simple. But the key point is not necessarily the export. The key is the workflow. Because you're going to work in Rhino and you're going to come back to GIS, and you're going to go back to GIS, you're going to work in. And the workflow is what separates the kids from the adults. The workflow is what turns you into a master of time and space. Like if all you know how to do is export, you're Disney World, you're kindergarten. It's like it's not real, but you need to like understand how things work together. So what I'm going to show you guys is basically the process that I do to ensure that the workflow is continuous. So export to CAD completed. So it's done. What I always do before I do anything else is I just remove the layer in ArcGIS first, because when you export it out to a CAD file, it wants to add the CAD file into your map, and that just creates a duplicate layer of a bunch of things that you don't need. So this is the CAD export. I know that because I saved it on my desktop, and this is it here. So I just select everything from that CAD export and I remove it. That's just cleanup. That's just good file management in your document. Okay. So in Rhino, before you do anything else, you want to make sure that your units, so I go to units, are set to feet, right? So right now it's set to millimeters, so I set that to feet. because the map is in feet, your model's in feet. So that's the first thing we do. Now we can hit import, type in import, go to desktop. Here's the CAD file that we just exported, Montgomery, Alabama. Hit open. It's going to give you a bunch of import options here. So model units are going to be in feet. Layout units doesn't really matter because you know, we're not working with layout space, but generally speaking, that should be in inches. So this is basically what the import settings need to look like. So then click OK. So now you see that it comes in. Now it's geolocated. So basically, the origin is right here. The origin is always at the center point of this little grid thing here in Rhino. So this export here is actually like far away from the origin, and that's good because this is geo-referenced now. So this whole layer, this whole data set here is all in the correct geolocation. So some things to keep in mind. Number one, when your model is geolocated, as it is in this case, that makes the workflow between Rhino and GIS seamless. So let me show that in action. Basically, if I create a new layer here, let's just create a new layer. We'll lock these here, and I draw like something. I'm just going to draw a rectangle in this space here. Imagine you're drawing the outline of a proposed park or whatever that you're working on, right? So this is a shape. We want to bring this into GIS. So we click on that shape, go to File, Export Selected, because I select that thing. Save it as another DJPG file. We'll call this one boundary, park boundary. Then export that as a natural. There's a bunch of options in terms of like what kind of CAD to export it as, but I always do 2007 natural. That's the one that gives me the best result every time. So click OK. So that's exported. So now you go back to GIS. You go to your catalog. In this case, I need to add the desktop as a folder connection. Okay. And then I should have the park boundary right there. That's the CAD export I just made. So you can now add in, if you expand that, you get all the elements of that CAD export. This is basically a polygon, so I bring that in. That comes in, as you can see, geolocated. It comes in the right location. So if you follow my workflow, you have your Rhino workspace, which is better for drawing and drafting. You have your GIS workspace. Everything is in the same location, so you can now work back and forth between the two programs. You can draw your shapes in Rhino, bring them into GIS, do something to this, bring it back out if you need to. Now, so this workflow is powerful for another reason as well. So park boundary. So now add another element here. Export selected. Save over park boundary. Save. Yes. Yes. So it just kind of goes back. Mastery of time and space. That's the key. The last point I'll make is this: is that this may not be an issue that you deal with today or tomorrow, but sometimes when you're dealing with 3D geometry that is really far away from the origin of the model, you can sometimes have what are called like artifacts and stuff like that. In this case, not seeing any, so it seems okay. But sometimes models that are located really far away from the 0, point in the model will have problems. It'll look weird. It'll look weird. So what I do in that case is I set up what I call a translation vector. It's a very fancy term, but all that basically means is this. I'm going to create a point in Rhino called origin. I'm going to just put a point somewhere, like right around there. I created a point, like so. And then I lock that layer. That layer never moves. This will never move. And then I take this whole, everything else in here, and I move it. I hit M, and I move it from that point. Let me turn on snapping. So we snap from that point, then move it to 0, 0, 0, like so. So that point stays there, but the model has now moved closer to the origin. And so now, if you model anything, it won't have as many artifacting, it won't have as many errors and that kind of thing. And then when you need to bring everything back into GIS, you just have to remember to move it. Just go in the reverse order. Move from 0, 0, 0, move it to that point, like so. And so you know how to get back and forth. You know how to go home and then go back to your modeling space. So this is just a handy way to make sure that when you're modeling things, that everything's nice and clean.